Hi everyone, this is J. Hariharan from UVAT University and I am studying in ECE department and my roll number is 24BQ180441. And today my topic is SISO, SIPO, PIPO and PISO, which is called as shift resistors. And let us discuss about the shift resistors. And before going into the topic, let us know what is shift register. A shift register is a digital circuit that stores and shifts the binary data through a series of connections connected flip-flops in response to clock pulse. The data can be shifted right or left as per our requirements or in a series or parallel. And first, let us know what is this Siso. Siso is nothing but serial input and serial output. S stands for serial series input and series output. SISO. Here we use D flip flop. D means D flip flop and Q3 is nothing but the output of this first flip flop. And D2 is the input of the second flip flop and Q2 is the output of the second flip flop. And likewise, we connected four flip flops here. And every this D flip flop's output is the input of the second flip flop. And the second flip flop's output is input of this third flip flop. And this third flip flop's output is input of this fourth flip flop. And we call this SISO, series input series output connection because it has input in series connection. This output is also connected in series. This is we consider this as the input and let us consider this as the output and both are in series connection only. And hence it is also called as SISO, series input, series output. And this is nothing but the clock. And if we insert some value, it will go on like this. First, LSB bit will be inserted here, and it will be shifted to this bit, and next bit is inserted here, and shifting will be done. And it is slow process, SISO. And let us know what are the applications of this SISO. It is simple and easy design to implement, and it requires very few data lines, means a very few wires, and it is useful for data delay. And hence we said earlier it is a slow processor and low hardware cost due to the minimum number of flip-flops and no parallel circuits. Ideal for applications and it is used for applications like counters, communication systems, and time adjustment systems. And let us know what is the Sipo. SIPO means series input and parallel output. Here input is connected in series and the output is taken as parallel. Here we see this input DA is input of the first flip flop and it is connected in series and this output of this first flip flop is connected to this output input of the next flip flop and this output of this flip flop is connected to the input of this F3 flip flop and the output of this F3 flip flop is connected to the input of the F4 flip flop and here this parallel, we call this parallel output because QA, QB, QC, QD, these all are connected in parallel. And it is QA is connected between the output of the QA and the input of the QB. Means it is connected in parallel. You will see how it connected in parallel. This is QA is the output terminal and it is connected in parallel like this upwards. And hence it is called as series input parallel output and CLK means clock. And let us see what are the applications of this series input parallel output. These are the applications, means benefits of this SIPO. It converts a series input into the fast parallel output, and we can get the output at every parallel. Means we should not wait like in SI S4, we should wait until n minus 1 sections to get this load. But here we should not wait that much time. We will get this when we give our input, we will get our output. And this is one important basic important topic in this Sipo. And it is used for LEDs and sound segment displays and other parallel devices. And it reduces the number of input pins required for the microcontrollers and supports long data transmission. And these are these benefits of this SIPO. And let us know about PIPO. PIPO is nothing but parallel input and parallel output. Parallel input means these inputs are connected in parallel combination, and output parallel output means output are connected in the parallel combination. And as we said, F1, F2, F3, F4 are D flip-flops. And this F1 output is connected to this F2's input. And F2's output is connected to this F3's input. And F3's input output is connected to the F4's input. And this output, we will take this output as QA and QB and QC and QD. These are connected in parallel like this. We drawn this to down because these are connected in parallel outputs. And we are giving these inputs in parallel, and hence we will call this as parallel input, parallel output series. And this is the most used shift register in this cell. Because as we give this input, we will get just output. We should not wait so much time to get our output. If we give 1101, we will get this corresponding 1101 in this output. But in a series, we have to wait up to n minus 1 seconds. But here, we should not wait up to n minus 1 seconds. As we give, we will get our output. And this is the parallel input and parallel output. Let us know this application means benefits of this parallel input and parallel output connection. Parallel input shift register. This is the fastest type of shift register because data is loaded and retrieved in a parallel, as I said earlier, and it is suitable for high-speed applications and data manipulation. And here there is no time delay. And as we apply our input, we are getting our output, and we can shift it towards as we like. And if we want a right shift, we can apply right shift. And if we want left shift, we can apply left shift. And here there is no time delay in the serial shifting also. And it is used for temporary data storage and automatic circuits. And it is used for buffering data between two subsystems. And it is used in ideal applications like CPU registers, the accumulator, and IR devices. And this is about this PIPO means parallel input and parallel output shift register. Shift register is nothing but this shifting of data and storing of this data. And we can shift it by two ways, like left side or right side. And this is means PIPO. And this is the last. This is the last shift register in this PISO. PISO is something but parallel input and series output. Here, this input is given in the parallel terminal, parallel ways, and this output is taken in series. And this is the corresponding diagram, and we will discuss how this happens. And here DA, DB, DC, DD is nothing but four flip-flops, and these flip-flops are D flip-flops. And here A1 act as this input, and B act as the input, C act as the input, and D also act as this input. And we will see A is act as this input for this DA flip-flop, and Q is the output. And this output is directly connected to this AND gate. G4 is nothing but the AND gate. And G4's another terminal is connected to this shift load. And here G1, and we will take another AND gate, and one terminal of this G1 is connected to the shift loads not get complemented. Means if you give 0, you will get 1 here, and if you give 1 here, you will get 0. And one terminal of G1 is connected to this, and another terminal of G1 is act as this input, parallel input, as we said, parallel input and series output. This B also act as the parallel input. And G4 and G1 values are connected to this OR gate. This OR act as this G1 plus G4, and this value is sent to this DB, which acts as the parallel input, and this output is connected in this series. And DB is input, and in second case QB is output, and QB acts as the output. This output value is connected to this G5. G5 is another AND gate, and G5's another terminal is connected to this load is shifted. And the GT is also another AND gate. And AND gate C is another parallel input. We will give four parallel inputs because there are four flip-flops, and these flip-flops are D flip-flops. And G2 is another terminal is connected to this load. And G5 and G2, these both. OR gate, and these both values are connected to this OR gate, and it acts as this input for this third flip flop DC. And this DC is the output QC connected to this G6 and G3, and like this circuit will work. And this is the parallel input and series output circuit. And let us know what are the advantages of this parallel input and series output. It converts the parallel data into the series data from transmission. Hence, we call it as PISO. And it reduces this number of data lines. Data lines is nothing but the bytes. That is considered as a bytes. And it enables fast loading of the data in a parallel and slow transmission series. We useful in keyboards. We use keyboards for computer operating and everything. It uses as this keyboard. And it uses as switches for many inputs and must send serially, and it helps interfacing with wide data buses to serial communication channel. And it is efficient for multiplexing many signals in one data. And this is the topic which is PISO, PIPO, PSISO, SIPO. And these four are the shift registers which are used for shifting the data or storing the data. And we can do the shifting on the right rows or left rows. And starting to ending this, we have discussed only right. And if we want to discuss left, we have to change some parameters, some connections in that, and we can get from left to right shift also. And maximum mainly we will use this right shifting of this shift registers. And these are the methods we are using: PISO, SISO, PIPO, SIPO. And we will use many methods to do this active shift registers. And this is, and thank you.